So today's going to be kind of a free-form lecture. We're just going to kind of nuzzle up to a couple of different topics. I want to talk about arrays. I want to talk about a replacement for using scanf. You know, in Microsoft we keep getting yelled at for using scanf. There's a very good reason why. I want to talk about pointers and structures. Let's see if that will be enough, because I think that could be plenty. Oh yeah, and Typedef. What does Typedef do? Typedef allows you to redefine one type as another. You can say, well, this language doesn't give me a bool data type, so I'm going to typedef the integer to be my bool. And then you can create variables. It's like doing that macro definition, except typedef, actually the compiler understands it and debugging tools understand it. Whereas with the macro definitions, it's just doing, you know, text replacement. And so, you know, things that are inspecting your code in order to understand what they're doing don't play as nicely with macro substitution as they do with Typedef. So I launched Sigwin. I'm going to make myself a new directory. I'm going to make myself a brand new file, touch June27.c. Then I'm going to go open that with TextPad. It'd be nicer just to add TextEdit to the search path so I could run it straight from the command prompt. But there we go. There's my C file.
You didn't change directories before you created.
That would be why. All right, CD June27, touch June27.c. Now it's there. Thank you. Okay. So I'm fairly certain that we're going to be using a couple of different header files. So I'm going to go ahead and just throw them in at the very beginning. And I really want line numbers, because when I compile things and I get my error messages, I would like line numbers. So configure, preferences, view, line numbers. All right, now I'm happier. Okay, so # include some stdio.h. # include, let's go ahead and get string.h. # include ctype.h. and # include stdlib.h. Now, I really ought to wait until I absolutely need one of them to bring them in, but just to save a little bit of time from the compilation errors when it doesn't know what it is. Alrighty, so int main, system pause if you're feeling it, but I'm not, because I'm going to be running everything from the command prompt, so I don't need to be pausing. Okay, so let's make a bool data type. Typedef int as bool. Now we'll need a little bit of a macro in order to do true and false. So # define true to be 1, # define false is 0. Now we can create variables of that type. Bool be okay is equal to true. Bool be hungry is equal to false. If be okay, now just to be fancy, I'm going to start using fprintf rather than printf. Fprintf, please send this to standard out, std out, comma, I am okay, \n. Now if not be hungry, fprintf std out, comma, I am not hungry. And by the way, if you feel like it, you could write a CMD file that this editor could run every time you wanted to compile something. Just like there's these external tools for compiling Java. People taking Java and using TextEdit for that may be doing that. But you can write a CL script to do it. I can give you one because I've been doing it like this. I'll probably upload it. Anyways, I want to give this a shot. So I'm going to go back and compile and see what, whoops, I didn't add my return statement. I really want to, even if the compiler wouldn't yell at me about it. All right, let's see what I've done wrong. I don't have a make file for it, so I'm just going to do gcc june27.c. Great, it worked. So gcc june27.c minus o june27.exe. And then dot slash june27.exe. It says I am okay, I am not hungry. So we have used Typedef to create a replacement for the bool data type that we were missing. Now, did we have to do that? No. But it's nice to be able to differentiate the purpose of our variables. This language doesn't let us write classes. But we could at least provide some distinction from one type of variable to another one. Like, what if we're going to have a whole bunch of molecular mass measurements in here? We might want to define, or typedef, the type double as mmass. And then every time we felt like adding, creating some molecular masses, the molecular mass of oxygen equals 16 point, I don't know if it's 00 or 0.01 or whatever. And the molecular mass of hydrogen is 1.002 or whatever, you know. These aren't necessarily right. Now, really underneath it all, these are doubles. But if you were looking at some code and you saw a function written like this, void, you know, calculate moles, and it took a molecular mass measurement, and then it took the grams, and then it returned one divided by the other, return the grams divided by the molecular mass. Then when you were looking at it, you could go, okay, I know that what I'm expected this function to be giving me is a molecular mass. A good compiler would even complain that we might be sending the wrong data type to it. Now, I don't know if GCC is going to give us that warning or not. But say I have 32 grams of oxygen and I want to find out how many moles it is. So double moles is equal to calculate underscore moles oxygen, and I have 32 grams of it. Alrighty. Oh, well, that was done. I made calculate moles return int. Excuse me, I made it return void, but here I'm trying to use its return value. So I need to change that to a double. Well, that was wrong. Okay. All right. Now, I didn't print it out. So anyways, you can use Typedef to try to make your code more readable. What is this variable? It's a mass. What is this variable? You know, it's a velocity. What is this variable? It's a this, it's a that. Now, honestly, when I was doing professional programming, I really did not use Typedef all that much because you're basically just changing, right? I mean, you're pretending that there's a type called molecular mass, but really underneath it, it's just a double. And if it was actually
a type-safe compiler that would complain if we passed in anything else other than molecular mass there, that'd be great. But I do not believe it is. If we do this, moles is equal to calculate underscore moles, and I pass in an int, something that's not an actual molecular mass value, I do not think the compiler is going to complain about it. Well, we can find out. How about if I display all errors? GCC, capital W, ALL, June27.c. Well, it's giving me some interesting information, which is that I set some variables and I didn't use them, and I had an unused variable, but that's okay. Okay, so unfortunately the compiler isn't being sweet enough to tell us that we're passing in data of the so-called wrong type. And the reason why is because C is quite happy to convert an int to a double. No problem. Another time when Typedef is more useful, a little bit, is when you're using structures. We're going to create a structure, and we did this a little bit on Monday. We're going to create a structure that's got a couple of pieces of information in it. Maybe just somebody's first and last name. But then we're going to create some typedefs for making declaring the structures just a little bit easier. So struct person, and what a person's got is they've got a first name, char f name for first name. We're going to say that their name can be 80 characters long, and then char l name for last name, 80 characters long. Now if I want to create a person, I can do that. I have to do it like this: struct person Bob. And then I would want to initialize it. So I'm going to go ahead and initialize it on the fly. Bob, comma, Roberts. Struct person Becky is equal to, quote, Becky, end quote, comma, Johnson. If you are a C++ programmer or a Java programmer, you'll be wondering why we have to precede the declaration of our variables with the word struct. You don't have to do that in Java. You don't have to do that in C++. But in C, you do. You do have to prefix your variable declaration with the word struct. It's not smart enough to know, oh, I want to create a person. Well, that person is a struct. But you can typedef it. So here's what I'm going to do. You know, our general rule in C++ and in Java and everything is to make our classes all uppercase letters. Well, I'm going to make this a lowercase p. So it's going to say struct person lowercase p, but I'm going to come down here and I'm going to typedef struct person to be person with a capital P. And now I can declare these variables without using the struct keyword because it knows what a person is. It knows that a person with a capital P is really a struct of this class, excuse me, of that structure. And another thing that people tend to do is to use typedef to create pointer classes. I could create a pointer to a person and just call it pperson. So why don't I do that as well? Typedef struct person star pperson. A pointer to a person. I haven't compiled recently. I hope I haven't broken the code. Just a second, I think. Expected a semicolon before the word struct. Line 25. Oh, I forgot. Unlike Java, C and C++ require you to end your class or your struct definitions with a comma. Excuse me, semicolon. I left that out. Okay, so far so good. I have a person structure type, and I have a pointer to that type. So if I feel like making a pointer and assigning it one of these values, I can. P-person, I'm going to just make a pointer to person1. No, I don't want to call that PP. I'm wishing I chose a data type that didn't begin with P, because I like lowercase p very specifically to mean pointer. I'm just going to run with it though. P data, how about that? P data, and then I can set P data equal to the address of Bob, and then I can send that to a function in order to do something with it. Now some people would say that that's too clever by half, and you may as well just define it like this. Person star P data 2, and then P data 2 is equal to the address of Becky. And I could kind of agree with that. I'm not totally sold on the idea of declaring two different types, one for the type itself and one just for the pointer, the type for its pointer. But you could do that. Okay, so let's make a class, let's make a function that accepts a person and print some information about it. How about void print person? And it takes a person as its argument. So fprintf standard out. First name is %s \n. per dot fname. fprintf std out comma last name is %s \n per dot lname. So let's print one person out, print person, and we'll pass Bob to it. And then print person, let's pass pdata2 to it. And what did we set pdata to? Pdata2 holds a pointer to Becky. So the first one is going to print out the information for Bob. The second one's going to print out the information for Becky. Or not. Invalid type argument. Oh, it's asterisk. What am I doing? Ampersand means address of. That's how you generate the pointer. The asterisk itself means dereference. Turn that pointer into, a valid variable that can be accessed. So, don't think I need to add that comment a second time. Alrighty. Alright, I'm still have unused variables and things that are set but not used, but that's okay. Do we have lint? Nope. Okay. People used to run a program called lint on their C files. And what lint would do is it would inspect it very, very, very closely, looking for all sorts of possible errors. And might be interesting to download it and play with it. But okay. By the way, I did just install my first tar or file that I had to tar and then to run make on, and it took 30 minutes for me to get it, but finally got it all. So for our Linux fans, I felt like a real Linux grown-up when I did that. Okay, so far so good. Are anybody getting any weird errors that you wish was corrected?
Yeah.
Oh, well, I should have stopped earlier. Oh, yell at me, get me to stop. What's the first one?
Okay, first one, this is on this side of this one. Just on this Terminated character.
On 219. Okay, well, go to line number 2.
Oh.
Oh, yeah, where do you know? All right.
Maybe if I just pay it. Alright. And then
Make sure you save it. Usually just fix 1 or 2 and then recompile. Or you could add the word struct in front of it. Either one would have fixed it.
Or I'd start to find it.
Right.
Either one.
I'm not sure you saved it. I think you made a change and didn't save it that time.
There we go. No, it's still saying.
And make it a lowercase b if we're going to do that.
Okay, now it's bool be okay, true. Here.
Okay, do we have our Typedef for bool?
Yes.
Effective semicolon. Alright, let's go look at it. And maybe see the line above it. So I'll go back down to line 49. Yeah, calculate moles.
Oh, that's
Just ran out of typing. Type 2, 32. In parentheses. Semicolon.
Oh, here.
Right.
I think so.
Slow me down, don't let me get that far ahead of you. How you doing?
Mine's running.
Okay.
Question though.
Uh-huh.
When and why would I want to use a pointer?
You use pointers when you need to change data inside of a function. That's one time. And another is so that you're not passing around large chunks of data if you can just pass around a single byte that represents a pointer. Very good question, and I'll repeat those when I get back up there.
Okay.
All right.
When I used Printf, it gave me something like I gave him too many arguments.
Oh, really?
So I had to switch it.
So you just switched to Printf?
Yeah.
That's odd.
But it made it, I kind of wrote everything wrong.
Yeah.
You know what? I think I forgot the STD out.
Oh, that would probably do it. Okay, so the question is, why in the world would you use pointers to begin with? Firstly, I want to mention why I'm using Printf. Because I want us to get used to the idea of handling files as well as console input. And if we're using fprintf and we're using fgets to read our input in, then we're already 3/4 of the way there. We just have to send in a file pointer rather than, std in or std out. Another is I want to show the idea that you can send things to the error stream and you can see them even if you redirected them. So if I do this, fprintf std out, comma, can you see this question mark /n end quote in parentheses semicolon fprintf, whoops, and then the same line, fprintf std out, but not std out, stderr, comma, can you see this? With 2 question marks just to differentiate the two. /n end quote in parentheses semicolon. Okay, so when I run it, it says, can you see this, can you see this? Now, I could pipe its output, I could redirect its output to a file. The term pipe means something very specific and not what I was about to use it for. I can redirect its output to a file. I can type this. Same command, but send its output to a file called t.txt. Notice that it's saved all of the output, and then if I go and I cat t.txt, if I display t.txt, I can see, all the output except this line. This one got sent to standard error, so it displayed on the console, the terminal anyways. It did not get redirected to the file. Maybe you wanted it in the file as well. Well, you better send it out twice, once to standard error and once to standard out. So standard out can be redirected to a file, standard error cannot. And that can be a good thing, because if you run a program, maybe you're generating tens of thousands of lines of data, you want them all to be saved to a file. But every once in a while, like if there's an error or a warning message, you might want to send it to standard error so that even if it has been redirected to a file, the console operator can see it. And while I am talking about redirecting things to a file, say you have a bug that involves your macro definitions, your preprocessor commands. And for the life of you, you can't figure it out because you don't know how it is being preprocessed, what it looks like after the preprocessing, the string substitution occurs. You can tell GCC to give you the preprocessed version of the data, of the C file. So GCC space dash capital E, and then give it your file name. Do 27.c. Excuse me, not GGC, GCC. All right, now you can't, it ran too quickly, but here's my file after all the preprocessing is done. Well, that's too much to see, so I'm going to save its output. Just to a file called t.c. And then if I notepad t.c, well, that doesn't look any good. I could open it up inside TextPad, or I could just cat it. And there it is, with everything expanded. And if we go and we find, let me open it up in here, t.c. Remember how we had a variable called hungry? No, we didn't have a macro called hungry, but we did have a macro called true and false. And so we see that the preprocessor has changed all the trues to 0, to 1, and all the falses to 0. Now we only have 2 preprocessor commands, so it's not that interesting. But if you cannot figure out why your code won't compile because of a preprocessor mess, run the compiler, use -e, save its output to a file, and then go down to that line and see if you can figure out what's wrong. Maybe we can give an example. Nah. Unless we actually run into that case, I'm not going to worry about it. So say I want to litter my code with debug messages. I will get to the pointer. question again. We did this once, but I want to do it one more time, which is I want to use the preprocessor commands to define ourselves some debug functions. And I want to make two versions of Printf. What I want to do is I want to make a debug version of Printf that we can call to send something to both standard error and to standard out. So I think I'll just call it print E for print error or something like that. So that's what it's going to be. Let's do # define debug. And then we're going to do this. If ifdef debug # define print error 1. You'll see why I'm putting this number on here. X. And what do I want that to do? Well, I'm going to put two little braces here to hold my code. I'm going to put a semicolon there. And this is going to say F printf std out, comma X in parentheses semicolon. And then it's going to say F printf std err, comma X. Semicolon. But if debug has not been defined, I just want to define that function as nothing. And I shouldn't be putting spaces there, but it helps it. I mean, when I say I shouldn't, the spaces are unnecessary, but they help read. So if that's the case, then we're going to define print error to be absolutely nothing. No code will be generated for our debug messages, for our print error command. So I could come here and I could do this. Print error 1. Uh-oh, an error occurred. I also want a version that lets us print out more than one thing, like if you have %s, right, and you wanted to print out a string, or %d to print a number. I can't do that right now. Well, firstly, let's make sure this works before I get too far ahead of myself. Seems to have. Okay, so it says, uh-oh, an error occurred. Uh-oh, an error occurred. Can you see this? Why are we getting two different copies of it? Because one of them is going to standard error. So if I directed its output to a file like this, t.txt, then I could still see that error message. Now I want to use a preprocessor to let me print out something with more than one parameter. So my name is, I forgot a \n, so I'm going to put a \n here. My name is %s \n end quote comma Jeff end quote in parentheses. Now this macro expansion is not going to work. So if I come over here and I run it now, it's going to say macro print error passed 2 arguments but takes just 1. And so the problem there is that our print error macro is only accepting 1 argument. and that is its argument. So we have no ability to pass in a second argument. And this language does not support the idea of overloading. If you've done C++ or you've done Java, then you may be comfortable with the idea that you can overload your methods and you can overload your functions to make one function have the ability to take in multiple different types of data. Well, we don't have that. So take this line here, copy the whole thing, paste it. Now we have two copies of it, right? But make the second one look like this, where it says x, make that x comma y. And the same thing over here, x comma y. And lastly over here, x comma y. But I can't call it print error 1. Every function has to have its own name. Every macro has to have its own name. So I'm going to call that one print error 2. And if I wanted to just print out one argument, I would call print error 1. If I wanted to print out two arguments, I would call print error 2. But if I'm not going to be running in debug mode, I still need to have the macro defined, but it's just not going to do anything. It's not going to be expanded at all. It will be removed from the code. Now, should error messages go away like that? Nah, this is basically just an example. We should have called it debug rather than print error. So yeah, as a matter of fact, I can't handle it. I'm going to change those words print error to debug. So there's debug 1, debug 2, debug 1, and debug 2. And down here, when I was trying to print out the second thing, the thing that had two arguments, it had the formatting string and the data being passed to it, print error 2.
Don't you have to change them to debug?
Pardon me?
Don't you have to change those print errors to debug?
Yes, I do. Yes, I do. Yes, I do. I don't know why I didn't. I got distracted on my way to do that. Thank you. Debug 1 and debug 2. All right. So if I run it, it is sending a copy of each one of those debug messages both to the console screen and to the redirected file. But if I undefine #define debug, if I comment this out because I don't want those debug messages in my output anymore, then when this macro gets expanded, it essentially just gets removed because that gets replaced with nothing. And so it didn't display my messages. Uh-oh, an error occurred. My name is Jeff. And if I wanted to, I could look at the preprocessor output, and I'd be able to scroll up and down, and I would be able to see how those macros were expanded or how they were not. All right, so back to pointers. Why do you use pointers? You use pointers for a couple of reasons. One is that it is a very efficient way of passing around large pieces of data. When I printed out this person, PER is a copy of whatever data was passed into it. Now forgive me, but I'm going to move these debug statements and I'm going to cut them and paste them above this stuff at the top of the screen because I want to be able to see this person's stuff, have it on the same. Well, now I have way too much of this stuff. All right. Kind of kept it all around, but it's in a different place. Okay, so when I called print person here, I have this variable. C is a pass by value, pass by copy language. So this variable is not the same as this variable. So it has to copy all the data that is into the structure as it's going on its way in there. If the structure contains several kilobytes worth of data, then the function sits there. The computer sits there copying in several kilobytes of data so that we have a copy of the data to play with. If I made this a pointer, by doing that, there's a syntax change I'd have to make. But when it called print person, it's just printing a pointer. A pointer is just an address. It's like 4 bytes long or 8 bytes long. It's one of the two. I forget the size of a pointer. I think we printed it on the first day. We could do that again. But it's just 8 bytes rather than 8,000 or 80,000 or however much data you may have in that structure. Now we have a change that we got to make in a couple of places. If you're printing it, if you're referencing something from a pointer, you can't use the dot syntax. You have to use the arrow syntax. And that means when I call it, I have to pass in the address. So I would have to change that. I would have to take out away the star there because it's expecting a pointer now to a person. It's expecting a P person. I wonder how badly I've broken the code in doing all this. Where'd Sigmund go? Okay, so that I didn't break it. Okay. So, I hope I can get across the idea of pass by value. C++ lets you, and Java doesn't, but the Java programmers, lets you pass things in by reference, which means I'm not only giving you a copy of my data, I'm actually giving you my original variable. C doesn't have that ability, neither does Java. But C does have the ability to let you pass in a pointer to your data. So what it's like is I create a person, I write down some name, somebody's name, and then I give you the address of that, and you can go and look it up. I told you to go and look in mailbox 1 for all that data. So I don't have to give you that entire package, I can just give you the address. I can go and say, look at this address, and you can pull it out. So you can get some incredibly significant performance gains by passing things around as pointers, rather than passing them around as structures. Is that part of it makes sense? Okay, here's the other reason you use them, is because if you have a pointer, your function can change the data. If you don't have a pointer, your function can't change it unless it's going to return it back out of it. So let's write a function that accepts 2 integers and adds them up and passes them back. So this is, it's going to be void just for some weird reason, because we're demonstrating something. We're going to call it add. And what's it going to take? It's going to take 2 pieces of input, int I1, int I2, and then it's going to pass something back in an output variable. And so we would say O is equal to I1 plus I2. Let's test it out. I'm going to declare a variable called result, and I'm going to call add. I want to add 1 plus 2, and I'd like for the result to be stored in result. But when I try to, it's not going to give me any results that I want to see. I'm adding 1 and 2, so I would like for my result to be 3. Okay, and the result is 0. It's not 3. And the reason why is that this parameter is just a copy of whatever was being passed in there. Say I give this guy a value, and then I run him. So since I initialized it to 10, this function wasn't able to change it because it just got a copy of it. It's like I handed it a photocopy of my data. I handed it a photocopy of 10. Yeah, it can rewrite on that photocopy. You can draw a mustache on it or whatever, but I still have my original data. If I wanted this to be able to be changed, I would have to pass it in as a pointer, which would be okay. But here's what I would have to do. I would have to state, no, he is a pointer. So I put a star there to indicate that this is a pointer. I changed the name of my variable just because I want all of my pointers to have the name P, the letter P in front of them to indicate that they're a pointer. Personal quirk, but it's a very common one. And so now I'm going to do this. Star PO. Use this pointer as though it was an integer. And now we are changing its original data. We are actually changing the contents of the result variable and not just a copy of it. I closed it again. All right, it says expected an int star, but argument is of type int. I made a mistake. And my mistake is that I need to be passing this in as a pointer now. So I'm going to put ampersand there. And where have you seen that before?
Scanf.
In scanf, exactly. That's how scanf is able to change the value of that variable to pass something back, to pass back your integer or whatever you let them type in. All right, and so this time it was actually able to add 1, 2, and get back 3. So does that make more sense?
Yep.
Okay. All righty, let's talk about arrays. The first introduction to arrays is usually in the form of strings. Like if I do this, char name 20 is equal to Bobby. This is actually an array. It's an array of characters. We could print out each one of them, each letter, with a little loop. Let's do that. Can't declare my variable inside it. Int I for index is equal to 0. For I is equal to 0. I is less than 20. I plus plus. Now why less than 20? Because our array is allocated to 20, meaning that we can access values 0 through 19. C, like most of the languages you'll ever use, lists are done with 0-based indexing, meaning you start counting at 0. So if you declare something to be of length 5, the way that you get a hold of them is you say 0, 1, 2, 3, 4. So I would make this loop for I is equal to 0, I is less than 5, so that I would count out 0, 1, 2, 3, 4 to get a hold of all 5 pieces of data. Now I just want to print them out line by line. That's all this is going to do. I'm almost getting tired of using fprintf. Forgive me, even though I said I was going to I'm just switching to this. Okay, so name %d into brace equals %d %c \n, end quote, semicolon. Now let's pass in I. Let's pass in name subscript I, and then name subscript I. All right, and here's what Bobby looked like when it was printed out. These are the character values, and these are the ASCII values. And we can see that after our data, There's a 0 there. 0 is called a null. This is a null terminated string array, meaning that all of the data is stored there, and then the next character is a 0 to indicate the end of the string. So if we were processing this and we didn't want to see all the zeros, we could try to avoid that. We could do something like this. I'm going to comment that line out, and I'm going to modify slightly. For I is equal to 0, keep running while name subscript I not equals 0, semicolon I++. So as soon as it finds a 0 in the string, it'll stop. And so it printed out BOBBY. I kind of like you seeing all those zeros just so that you have the concept that they're there, that this is a null terminated string. For naming conventions, for naming purposes, people often prefix the names of their strings with the letter S. Name is a string. Or even SZ for zero terminated string. You don't have to do that, but you could. You may see me do examples of that. Now what if we want to let them type in the name? Well, we could use scanf. Let's give that a try, but then we're going to wind up doing something else. There's an alternative to printf called puts, which doesn't allow you to do any substitution, any placeholders. Let's see if this works. Now let's read in what they type. Scanf %s for string into parentheses, comma, name. Okay, so when I ran it, I entered my name. Notice I didn't have to pass in. I didn't have to pass it in by address. I didn't have to do ampersand to scanf, unlike when you're reading in a numeric value. And anyways, and so what we got back from it is that the first character is an 83, the second value in the array is a 97, the third one is 109, and the last one, if we had printed it out, would have been a 0. Scanf has big problems. Let's see if we can demonstrate the problem. May not be able to. May be able to. Let's find out. Change the length of name down to something short, like 4. We don't even need to initialize it now because we're letting ourselves type a name in, right? Let's go back to the first version of this for statement. The one that I want to see used looks like that. Well, we don't want to print out to 20 anymore because we only have 4 characters, but let's do that. Okay, so for I is equal to 0, I is less than 4, which is the length of the string, I++. We're going to ask for the name. We're going to print it out character by character. That's a pretty short amount of space. Enter your name. Bob. Bob fits in 4 characters, right? When we define it out to 4, since it has to have that 0 in the string, we're really only allowed 3 characters to play with. The 4th character has to be the 0 at the end. So Bob is the safest legal amount of data we can put in there. And when we do, it prints out BOB space. What would happen if we entered more than that? Jeff. Alrighty, JEFF, we filled up our data. It didn't complain about anything else, but what happens if I enter more than that still? Bobby Jones. All right, we don't even know where the rest of that data went. It's kind of a miracle that it didn't crash. It's kind of a hidden error. When we were typing all that data in, when I typed in Bobby Jones, the Y and the space and the J and the O and the N and the E and the S got stored into my program's variable data space. But I don't know where. I don't see the results. I don't get to see what it messed up, what it overrode. But it surely did. And if we ran this inside the Microsoft debugger, it would flag it as an error and cause a break because it's got, you know, cool debug versions of the executables that it compiles. Let's see if we can prove that it is overwriting something. So in front of name, I'm going to do this, char OK1, and all it's going to be is just the word OK. Why did I make it 3? So that I could store the O and the K and then the terminating 0. And then char OK2, 3, is equal to OK. After they enter their name, let's print out the value of all 3 of those strings. Printf, %s, 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 \n, end quote, comma, OK1, name, OK2. Now I'm going to enter to something to be long, something that cannot be held in just 4 characters. Bobby. So to look at it, when I print it out, it should have said OK space Bobby space OK, right? Because that's what OK1 was supposed to be. But it didn't print out OK. It just printed out Y. So by entering too much data, scanf corrupted this array, this string. So scanf is not a good choice. There's a better choice called fgets. There's probably just a gets version, but fgets will read from whatever file pointer you give it and store it in the string. And you can specify how many characters you want to read in. Change this back to a more reasonable amount. Change the length of the name back out to 10. We should make that a constant so that I don't have to keep coming down here and modifying my for loop to match. I made that a 10. So, instead of using scanf, I'm going to do this. Name equals fgets from stdin, standard input, and I want to get in 10 characters. That's the size of my buffer. You know, we could have left it at 4. It would prove the point. Too few arguments. Oh, my mistake. The syntax of it is it's not name equals, it's fgets, and then you give it the variable that you want to read into. Name, followed by the length of your data, followed by which pointer, which input stream to handle, which file pointer to use. Okay, so when I run it now, enter your name, Bob. It worked. Now let's enter something in that's too long. Oh, by the way, notice that there's something weird tucked away here. There's an ASCII value 10, which is not visible data. That's caused by the inner key. That's the line feed character. That's one problem with fgets. Fgets means read an entire line. And it did. But how does it know where the end of the line is? That 10. Now let's enter something too large to fit into 10 characters. George Washington. Here's what it got out. George Wa. It lost some data, but at least we didn't corrupt our strings, right? We were able to specify the size of the string that we wanted to pull out. And that's a very good thing.
The vast majority of programming flaws at one time were, or exploitable flaws, I should say, were buffer overrun attacks, which is where your program is expecting some input, and instead of providing a small amount of input as to would be expected, they would enter so much data into it that it would overwrite memory, and if you overwrote memory in just a very specific way, you could corrupt the memory and perhaps even, gain control of the machine by writing in, memory into a very specific place in memory. So that's a buffer overrun attack or a buffer attack. By using fgets, you prevent that. Well, I won't say you prevent it. You go a good way, because I typed in more data than what it was expecting. But it didn't cause a problem. I just didn't get everything that I may have wanted, right? I lost some stuff, but it's better to lose data than to have data corrupted.
So this is one of the unhappy things about programming in C, is having to worry about the length of your input buffers and your strings and stuff like that.
In Java, you just say, hey, I want a string, and I don't care whether the string is going to be 1 or 1,000 pieces of data in it. Here, we had to allocate how many characters we wanted our name to be. We took a guess. Well, I think names can fit into 10. Well, I bet your name doesn't fit into 10 characters. So, yeah.
So wait, when you do char, you don't have to put a number on there, do you?
If you don't put a number on there, you get just a single character.
Okay.
Yeah. Yeah.
Because I feel like I've done that and put a string in there.
What if you do this? Is this legal? Char.
I feel like I did like char x equals and just put a string in there before. I don't know if that's Java talking about or something. But Java uses strings, so.
If you don't feel like specifying the length of your string, of your buffer, I believe you can declare it like that. Let's prove that before I start bragging about it. And yes, if you don't feel like specifying a limit, you can just say, I have a string, it's going to be of this length, give me a pointer to it. An array and a pointer to that data type, as far as this language is concerned, are identical. So everywhere that we can use a character array, we can use a pointer to an array. However, if we try to write anything to us, it better not be longer than 5 characters. You still get into that problem to where you have to specify a length that is large enough to hold whatever you're going to override it with. Now, if you're just declaring it for your own purposes and you're not going to let anything write over it, hello, who's going to erase that word and put something else in it? That's fine. But if we're giving ourselves a place for them to enter data, that's when you have to declare a length that's larger than what you're expecting.
I'm going to look just to make sure, because I feel like I totally used char without the.
See if you can. Yeah.
I think I did like another.
Let's try that out. Char third is equal to, does this work? And so I'm going to print out third there. All right, initialization from a pointer. I'm not getting that to work. I'd be interested to see how you can find out how to do it, or if you remember which homework assignment you did it on.
But it may be like I'm thinking of something different, like Java or something stupid.
Well, absolutely in Java, you don't have to do any of this business about declaring declaring arrays in order to use a string. So the string type in Java makes that work far more easily. All right, I'm going to do a little bit of cleanup. Well, that's not going to work. It's not going to put the pound sign, the backslash in. Okay. Okay, so the exercises in the book, the examples in the book, when they show you or they ask you to write a program that will read somebody's name in, Adrian pointed out that they don't show you how to use %s on scanf in order to do it until a later place in the book. But that is how you do it. Here's how you use scanf to read in information. Read from standard IN to a string. The problem is that scanf will read into the overwrite data past the end of the string if given too much data.
Don't you have to do name?
No, because a string is actually a pointer. A character array is actually a pointer. An array is actually a pointer. That's why I'm able to print both of these things out using the same syntax. When I printed name out, I didn't have to use any special syntax. When I printed second out, I didn't have to use any special syntax. They look different, but an array is the same thing as a pointer in this language. And so since it already is a pointer, I can't use an ampersand there, or else it's getting the address of a pointer rather than actually letting.
No, I mean when you do the scan.
Right. And if it works, it'll be funny.
But I thought you have to like tell the scan where it's putting it.
All right, then why was I able to do it without having that?
I don't think you were.
Alrighty then. So the answer is no, you don't have to have the ampersand. And I'm frankly boggled that it works with the ampersand. The reason you don't have to do the ampersand is because a string of characters is the same as a pointer. And so the reason we do the ampersand is to turn that variable into a pointer so that that function can modify the data within it. So the %s in scanf expects a pointer to a character, not a pointer to a pointer to a char. but we've seen it works. Here's how they're doing it. Oh, well, this is wrong because they're not even giving any space to write into. So allocate the memory for the string variable and then pass only in that string rather than the ampersand string. The fact that it's working with the ampersand, I cannot explain why it is. It's not correct. Since name actually is a pointer in and of itself,
So
you don't do that.
If you use a variable, you should use the ampersand.
Yes.
And a pointer, you should just not.
Right, right. What if we were going to scan for a number, like we were going to ask their age? Int age is equal to 0. We're going to make a pointer to our age variable. Now let's tell them we want a name, an age. Now let's let them read it in. Scanf, %d. I would do ampersand age, but it's a pointer, so I don't have to. So printf %s, your age is %d \n. Name, comma, age. Okay, and so it says Bob, your name. So you saw that when we had a pointer to our data, we didn't use ampersand. And here, name actually is a pointer because all string arrays are pointers in this language. It blows me away that you can get away with doing this. I'm wondering if that's true of all compilers. But we just saw it could not possibly work if we didn't actually have the data, the place to fill in. I'm not gonna dig on it. You've broken my brain. My brain is broke. Can't explain why that would possibly work. And I closed Sigwin again. All right, I think we're going to stop so that we can talk about the exam a little bit. But honestly, with the exam, I'm just going to say, review the daily assignments. You know, go and look at your code that you uploaded each day. Review your homework. Look at the notes that I've uploaded each day, and then boom, you're going to master it. So let's. What was I going to do? Oh yeah, I wanted to prove one more time for myself whether that was going to work or not.
Is 27, right?
Yeah. I seem to be stuck on a week back. It is working, with the ampersand or without. The correct way is to do it without. Nope, I can't explain it. Alright, are there any questions over what we covered other than how it's possible for the same function to accept either a pointer to itself or a pointer to a pointer to itself, which is what scanf is doing there. Are we happy with what we did? Did I manage to break your code towards the end, or is it all still working for everybody?
You probably didn't type in everything that I did because I kept changing things. All right, so basically, what do I want you to know how to do? I could ask you to write a code that uses the preprocessor to define something, right? Define a constant, you know, called pi using the preprocessor, or using # define, make it so that if you don't like using the word printf, you can use the word wow, or something like that. And I want you to know the difference between an int and a float, and a double and a long, which ones, you know, support integer data types, which ones are floating point data types. I want you to have the idea of ASCII, you know, which is that it's a byte, and you can go and look on an ASCII table, like ASCIItable.com, and find out that an uppercase A in that byte is value 65, and so on. I want you to have the idea of the main method. Every function has to have a main method, and that we have to have our # includes up at the top. So if I ask you to write code, that'll print out, you know, please enter your name, please enter, you know, 2 numbers. If I asked you to write a little program that could ask you to enter 2 numbers and then provide their sum or something like that, you ought to be able to do it, you know, with a scanf and with a printf statement. We have talked about the make files. So if I ask you to explain a make file, or how to use it, or something like that, then you ought to be able to understand how to do that. You know, and we have samples of them that we have made. I wonder where I put my make file. In June 20. Yeah. So like that. What is this thing in front of the colon? That's called the target. What is this section here? How do you invoke it to trigger that action? Well, firstly, what's the command you use at all to run a make file?
Make.
It's make, right. What if I wanted to trigger this specific action? What do I do?
Make. Clean.
Yeah, make space clean. What if I don't specify anything? What is the first thing that gets performed?
You don't specify anything, like, don't
Yeah.
specify lane?
Yeah, the default
Yeah.
is that one. Right, if I don't specify anything, if I don't specify clean or any other target, the first target it finds in the make file is the one that gets executed. If I need to specify a file name,
If you didn't have that in there and there was only clean, would it only do clean?
correct.
Oh, that's weird.
Like if we reversed them. Yeah, yeah. So it is order dependent.
So you couldn't even access the other one unless you had you put a command for it to come.
Yeah, how could we now that we've done that? Well, what if I do my exe as main.exe? Can I do that? Make main.exe.
Oh, you're still in Notepad. You have to get out of it.
Yeah. All right. It was able to do it by providing a specific target that I wanted because this executable happened to match that one. And so this is like if we weren't doing the macro expansion, we had that in there. So I was able to run it. But that's the only way though. I've messed up my beautiful make file. Move back down there. Okay. And so our compiler flags know the difference between -o and compiling something without -o. What happens if you compile something without -o?
Just puts the file name, right? Like as the does it do the same file name as the .c?
We just don't get an output file. We don't get an executable output file if we don't have the -o.
Yeah, but you'll still get a file.
Let's go look.
You have to get a file.
Okay, right. We get our output file. Oh, come on, type it. But we didn't get to specify its name. And so with some other compiler switches, we can tell it that we don't want it to produce an executable, that we only want it to produce the object file. But that's what -o does, is it gives us the option to set its name. So by this point in the book, we have covered precedence. We could go back and hit the PowerPoints, and we'd see everything that we've lectured about. Wrong. So the PowerPoints will be available for you to look at. Not like you have to have a photographic memory. But it wouldn't be a bad idea to review them. What is a keyword? What is an identifier?
Our stuff we turned into?
Yeah, right. Anything that's uploaded to D2L either by you or me is fair game. So identifiers have specific rules, such as they can have numbers, but they can't have spaces. They can't start with a number, that kind of thing. Our basic types, we already mentioned that. How do you define a constant with these keywords CONST? Precedence, you know that multiplication happened before addition and subtraction. What ampersand means, 2 ampersands is an and, 2 ampersands is an or, but there's also logical ands and logical ors, which is where you're just comparing the bits of 2 bytes. Click to add title. That's my favorite slide. Alrighty. We know what comments look like. Escape sequences. How do you specify a new line as opposed to printing out with a tab, /t for the tab, /n for the new line? If you actually need to put a backslash in your output, you just put 2 slashes there. That has to be actually chapter 3. So there's a whole bunch of types. I do want you to remember the difference between an unsigned and a signed, which is essentially which one of them uses the first bit to indicate that something can have a negative value. Signed or unsigned? We have talked about that, right?
Yeah.
Okay, yeah. And so an unsigned variable, since it gets to use that bit, can hold a value that's twice as large as a signed variable. It's just that they can't go negative.
Are we taking the test here or?
Yeah, you'll take them in, take it in here on Monday.
We really have 5 PowerPoints over Chapter 2. And then none over Chapter 3. I'm confusing myself there. I know that I was that I got off and I was discussing Chapter 3 as though it was Chapter 2 and Chapter 4 as though it was Chapter 3. I will rename the appropriate one to Chapter 3. So we know what a loop looks like. We know how to increment, how to decrement. We know what an if statement is. We know what a while looks like. While x is less than 10, do something. Hopefully we remember the difference between minus minus c and c minus minus, which is that this happens before the expression is evaluated. This happens after the expression is evaluated. For loops, I will certainly ask you to write some for loops similar to our homework. Count from this number to this number. And then what a break does. All right. And we really haven't dipped much into Chapter 5. So pretty much think of it as being Chapter 1 through 4 plus make files and preprocessor. And feel free to ask me any questions during the exam. You can wave your hand if something is unclear. I will help you with it. If something is so unclear that I think that I need to explain it to everybody, I'll probably just come up here and give everybody the answer. So it's to your advantage to ask questions. Now, that doesn't mean you ask the first one, you ask the second one, you ask the third one, and I'll give you every single answer. But you're not gonna find it traumatizing. It's not gonna be that hard.
Are we gonna have to use Sigma?
I'm so sorry. Pardon me.
Are we gonna have to use Sigma?
It's not designed so that you have to use a programmer tool.
Okay.
But you can use one if you want. You can pop open Visual Studio or whatever if you want to write some code in. But it's not going to be, okay, I want you to write this program and debug it while the exam is on.
Okay.
Okay. Pretty much like you could take it with pencil and paper is the way it's designed to be. All righty. Are we all good? Any concerns, any questions? All righty. Well, I'll see y'all on Monday. I'll make a Dropbox. That's a good idea. Looks like I haven't given you any homework for today. I didn't have a homework assignment prepped, so if I come up with something that's simple enough that I think I could just post it by the end of the day, I'll direct y'all to it. If it's one that could be done without explanation. Otherwise, I may just say that your homework over the weekend is to work on your exam. I'll know by midnight tonight, so just I'll post a notice as to the effect of if there's another homework assignment. If there is, it'll be due Tuesday night. That wouldn't be fair, though, because y'all aren't coming to class Wednesday.
Yeah.
No homework on this one. Alrighty. Okay. So this will be Dropbox I. All right, there's a Dropbox side there.